you are very welcome to our presentation. My name is Ayten. I'm a master's student from Bauman Moscow State Technical University, and today I'd love to share with you a research on intensification of the flotation wastewater treatment with the use of vibration excitation. First of all, let me tell you what is flotation and why do we use it. Flotation is generally used to treat and clarify water. This enables water recycling from sewage, septic tanks, storm drains and other sites with contaminated water. Usually flotation is also used in production of petroleum, paper and food, where wastewater is contaminated with fats, oils and greases. Flotation begins when the water is entered into the septic tank, where air bubbles are introduced. First of all, air bubbles and contaminants exist independently from each other. Then contaminants attach themselves to the air bubbles, forming an aggregate, and then they rise up to the water surface, forming a froth. Afterwards, this froth is removed from the water surface and we get more pure, transparent and clean water. So nowadays, the flotation is described by the following multi-stage model and is determined with this set of equations. Here, C, A, B and C are the contaminant concentrations in stages A, B and C respectively. K1, 2, 3 up to the 6 are the transition constants from the one stage to the another. And in this work, K1 and K4 are of a special interest. For example, the first one describes the probability of the aggregate forming, and K4 the probability of the aggregate's loss from the froth. So in these formulas, I want to pay your attention to the value D. If we look carefully, we'll see that the smaller this diameter will be, the high efficiency can be reached. So our task was to find a way to make air bubbles smaller to get high efficiency. For this quite difficult task, the following experimental unit was created, and on the next slide you can see how does it look schematically. This unit consists from the column 4 filled with water up to the 5th level. Air bubbles are introduced through an aerator 9 by the use of the compressor 11. A shaker is used to send the signal from the generator 1 through the preamp 2 directly to the study object. During the experiments, which were carried out on frequencies from 40 up to the 200 Hz in steps of 5 Hz, we made pictures with the use of macro lens camera 6, and the calculation of air bubbles and the analysis of the investigated process was carried out on computer 12. For you to see how does the picture change during the experiments, I want to show you the pictures without vibration. Here you can see that air bubbles are quite big. We see that the distribution is completely not uniform, and of course the number of bubbles is small. On the next slide, with the use of vibration, we already see that the number is a bit increased and the size of air bubbles is decreased. And finally, on this picture, with the use of vibration, on the frequency of 170 Hz, we can see almost uniform contribution, small-sized air bubbles, and this can be a basis to think that vibration excitation helps to reduce the diameter of air bubbles. Now it's interesting how does the frequency influence on the size of air bubbles and their number. Let's have a look on a graph, and here you can see curves. Each curve is related to each diameter of air bubble and is marked by its own color. For example, blue one is related to air bubbles of 0.1 millimeters in diameter, whereas a red one is related to those of 0.2 millimeters in diameter. So you can see that these lines are collinear, and we can detect 3 resonant frequencies that are 55, 120 and 170 Hz. To compare the results without and with the use of vibration, let's have a look on the next slide. Here you can see that without using vibration, the number of air bubbles are less than 300, whereas in contrast with the use of vibration excitation, particularly on the resonant frequencies, you can see that this number is increased up to the 800, for example, in case of 120 Hz frequency, and almost 1200 air bubbles in case of frequency of 170 Hz. If we'll calculate the effective diameter of air bubbles, you can see that without vibration this diameter is 0.29 millimeters, which is quite big, and with the use of vibration we can reduce this number almost 2 times. Therefore, we can confidently say that the use of vibration excitation during the flotation results in decrease of the size of air bubbles and makes the bubble size distribution more uniform, in contrast with that without using vibration. And this distribution will depend, of course, on the frequency of vibration. And as a result, we can say that vibration excitation gives an opportunity to improve the efficiency of the flotation process. Also, I want to say that the research made during this work will be the basis for further studies of the vibration excitation effects, and we can find an optimal mode to carry out the multi-stage flotation process. Thanks a lot for your attention.